Hello. Welcome, gamers. It is Monday, and I'm here with another stream. That's right, it is a Monday stream, another pico-8 development game. Sorry, I said that wrong. Pico-8 game development stream, that's right. Let me welcome everyone first. Welcome Stream Elements, welcome ChocoJax, welcome Yuyuko, DFGG, Muffin, Dappins. Anyway. Can't wait for Wolfie to drop a title like pico-8. I've implemented the solution to global warming and enacted world peace. So true. So true. No, I'm not making a fighting game. This is simply to demonstrate hitboxes and hurtboxes or whatever, which I have implemented. I'm gonna give an update on the current status of my software that I've written. Hold on, let me move everything around. Got this thing. Welcome A. Pullen. You do programming too? I sure do. That is my day job. But not programming games. That is not a thing that I do at my job, but I'm doing it now when I'm done with my job today. Not forever, just today. Welcome Zoe as well. Alright, so if you'll remember last time, I gave an overview of pico-8, and last time we used someone else's ECS system / engine, and then after that I was like, I'm gonna make my own, and then I did. So I'm gonna show it. You're gonna be like, well, how does he do it? How does he do this? As back-end software development, I'm not a front-end engineer. That is not a thing that I do. Anyway, okay, so we got this this directory here. I'm gonna load everything. He invented it. That's right, I've invented systems. Alright, so first we're gonna load the program. pico-8 ECS test, what is it called? ECS.p8. Alright, now you'll see here, hold on, I need to update some stuff. We go to main. We go update our spawn thing to spawn 250 snowflakes. Okay, so this is what I have set up. It is a rat in a snowfield. There is snow, the rat can jump. I've not implemented logic so that the rat has to land before jumping again, so this rat can fly. We also have various collision detection. We have axis aligned bounding boxes outlined in red. And you'll note here that it does detect collision correctly. You can fall from great heights and still have it detected. You can... oh, look at that, that's a bug. It's a bug right there. That's not supposed to happen. I thought this was supposed to prevent stuff like that, but I guess sometimes it happens. Oh, that's wrong. I need to fix that. But anyway, look at this. You got things on the side. You can't go through them. You can fall off. And then you can continue to jump to go back up. And look, you can fall from a great height and still land. Look at that. It did not tunnel through the bottom like you would expect in some cases. If your velocity is high enough, sometimes you can just tunnel through things, but I don't know how to replicate what happened there last time I, went through this thing. You could tunnel through it, but I would like to prevent that. Anyway, I'm going to explain the systems that I've learned. Okay, I've learned so much this past week. Trying to implement stuff. I have my own ECS library now. So last time I was using this other one. What's it called? pico-8 ECS. It was a good library. I just felt like I wanted to make my own. Mine is actually fewer tokens, but it is possibly a little bit less flexible. Anyway, look at this. Okay, this is my setup. This is how to use it. So I've learned about how ECS works. There is two popular implementations. There is a archetype based one, and there's one based on sparse sets. I was going to implement it with the sparse set method, but then I was like, this is a lot of effort. And you also have to consider how you optimize your systems or whatever. Grouping, queries, and all that. Welcome Zeb. So I looked into implementing an archetype based ECS, and it works. It is actually quite good. So this is the system, okay? First we have components, okay? We have entities, we have components, we have systems. An entity you can call spawn, and you'll give it different parameters. Each of these parameters is a component, and then the value associated with the component is stored along with it. And then once you have components and entities, you write systems. And these systems query things that have the required component. Also welcome Stanley. And then you pass it a function. You give it a string that tells you what you want to exist. I could have had this as, you know, passing in the different strings separately. You could do something like this. But then I decided to have it as one string because that saves on tokens. If you're familiar with pico-8, they have a token limit. So all the tokens you can save are better. So once you define the system, it's going to parse the string. Just do like splits on commas, and then it gets the field names. These are the components that you want. And then it'll give you a function. The function will have the things you asked for. But it also allows you to pass in an additional argument, so that when you call the system, you can pass in whatever you want. You can pass in multiple things if you want. And then once you're in here, you have access to the fields, and then you can update them. So if we look at a simple system for velocity, for example, what is it called? Movement? Did I call it movement? Yes, there's a function called movement. And basically all this does, any component, any entity that has both a position and velocity, you will run the system on each one of these, and then you can update the position based on velocity and delta. And I'm sure this is so interesting. You're like, Wolfie, what does this mean? I don't understand. Well, you can use it to implement many interactions between objects. So I've also learned about collision systems. In many games, you want it so that your character can't run through tiles. Like this, you know, you can look at that. That's broken. It is simply broken for some reason. I need to fix that. But you know, generally it kind of works. But then the way it works is actually quite interesting. I never thought about this. I always thought it'd be like, you know, you detect when you're colliding with an object, and then, you know, you simply increment the thing such that it's above the object once the collision has been detected. But then I learned there was a thing called swept AABB. And AABB is a axis aligned bounding box. And then the swept algorithm is simply a way to prevent collisions before they happen. So you have this rat, right? This rat, it has velocity. It has a collider component, which I've defined. And then before you update positions, you do a check about where it's going to go, and then you check whether it's going to collide with something. And then if it is, you calculate the time of collision, and then you do collision resolution. It's actually very cool. And I'm sure you are all super interested in knowing exactly every detail about this. You're going to be like, Wolfie, what is this? How do you implement, what is a parametric equation? I don't know. Welcome Ronmu, welcome Ristatter. So we've implemented many things here. We have vec2, that's right, vec2o, it's right here is defined. We have ways to add vectors, multiply vectors, normalize a vector. I don't actually use this anywhere, so I could probably remove it, but it is there, it does exist. And then I've defined an axis aligned bounding box. You can calculate the center of it, the size, you can expand the bounding box, you can get the offset, to check whether it's colliding with something else, and then you could do swept collision detection. Welcome Hongtown Deluxe. Did a presentation on collisions? Well, then you should know this. You probably know all of this, and you could be like, Wolfie, you did it wrong. This one you should have compared with the other value instead. So a way to do it is to intersect array with the bounding box. And that is the way I've implemented it. I also have some debugging functionality for drawing a rectangle around things. Welcome, Handflow. I have defined a way to define one of these bounding boxes by the center and half extent. You think of like a box, right? This box is right here. You have the center, and you have half the height and half the width. And then you have, then you do ray intersection. This one, I spent all of yesterday trying to figure this out. And I think part of the issue was that in pico-8, when you divide by 0, it does not result in infinity. It results in the largest possible number, which in this case is like 32,000 something. And then a lot of the articles online assumed that once you have infinity, the rest of this math works. So I spent a long time, I copied code exactly as it was written, and then it was like, it didn't work. And I was like, what's going on there? And then I simply, I don't know, I eventually figured it out. A lot of things, look at this division we're doing here. A lot of things cache this division because dividing is an expensive operation. So they'll do like 1 over ray direction, and then they'll save that as something. And then instead of doing this here, they'll do this. And then I did the same thing. Sorry, they'll multiply it. They'll do this. And then I was like, sure, I'll do that. It doesn't work in pico-8. You actually do have to do division because then the math works out that way. I didn't realize it took me the entire day and I figured it out. Welcome, Son. Any idea what game I want to make? I have some ideas. I don't know if I'll be making a game today. I'm just going to be refining some systems. I'm going to have some collision resolution. You can make it so you can bounce on objects. You know how like in games you have platforms that you can like jump through from the bottom? Maybe I'll implement that. I don't know, a lot of stuff. I was doing particle collisions with boundary conditions, turning collisions into an upper triangular matrix. I don't even know what that is. I don't even know what that is. The 1 over ray there just vanishes. It becomes a large number, which is not infinity. A lot of things assume that once you have infinity and you divide things by infinity or multiply things by infinity, you get not a number. And then they rely on NAND propagation to have the math be done properly. And I assume it would work here as well, but it doesn't. Anyway, you have to actually divide, otherwise it's broken. And then you do a bunch of math, a bunch of really weird math. And then you return the time of intersection and also the normal. So if you're like jumping onto something from above, it'll give you the normal of the surface, so it's like -1 pointing up. If you collide from the left side, it'll give you -1 on the x component. Collide from the bottom, it'll give you like 1 for the y component, etc. And then once you've detected a collision, you simply just resolve the collision by changing the velocity of the object being collided with. And then that's how you handle it. And then like theoretically, this should handle cases where you're going really, really fast. You should not go through the box, but it does. Wealthy Hitbox is promising. Welcome Tang Barrel, welcome EKR numbers. Hope you're all doing well on this Monday. Anyway, it was actually very enlightening. I now understand how collision works in games. And it can be represented in, this is all it takes. It can fit on one screen. I mean, okay, there's more complex situations like intersection with circles. There's like other stuff, I don't know. But this is like basically this is the core logic. Welcome Slime Molder. Yeah, it's very cool. I could also go over the ECS implementation. This all fits in 119 lines. Basically, okay, I don't know how technical you want to get with this, or how technical I want to get with this. What if I open up Paint and explain them? Okay. But basically, okay, you have components, right? You think of it like you have everything has like a velocity and position, maybe acceleration, sprite. Did I spell this wrong? Acceleration. Let's increase the font size to 18. You have components, okay? Every component, I map this thing to a binary representation. So this will be like velocity, we have like a number, okay? Like 0, 0, 0, 0. You have like 1, 0, 1, 0, 1, or whatever. So then velocity, we're simply using bits to determine what component something has. So velocity is this one. If it has velocity, this will be set. If this has this one, this gets set, etc. So then it's very easy to determine. Oh, I didn't put a 1 in there. So let's say there's another one. Welcome Denchi. We have this one, right? This one right here. How do I move things in Paint? What's the what is the button? I don't use Paint. Okay, well, assume this one is this one. There we go. We have this sprite is this component right here. There is a 1. Got the 1, 1. Storing multiple pieces of info in one variable. It is simply a bit set. There's nothing you can area select and move though. It's very strange. If your selection is too small, I guess it's like hard to move things. Select all, I don't know. Anyway, so you define components, right? For example, in here, a component that we have many components. Position, velocity, sprite, physics, controllable, collider. One limitation with the system that I have is that I assume you will have no more than 32 components. If you do, I'll have to re-implement everything. Not everything, just like a bunch of stuff. It's doable, it's just, it would be a little less performant. Because every component will be the presence of a component represented by this. And then you could do very simple comparisons to check if a system depends on whatever. Yeah, no one could need more than 32. Look, I've written this whole thing and I only have what, like 6, 7, 8. I only have 8 components, okay? All you need are 8 components to implement this entire system. And that's not even like a fourth of it. Okay, it's exactly a fourth. But it's, you know, there's much room. But if you do want to have more than 32, I have implemented a bit set, which I have not used in here. But there is a way to use more than 32. So like instead of just having 1, it's like you have 2 numbers instead, or 3 numbers, or 4, okay? But you can do it at some point. Anyway, the way that this works, okay, I'm sure this is very interesting to you all, as it is to me. You're like, Wolfie, please explain what an archetypical ECS is. Okay, you know, if you're gonna ask, I will explain it to you. It's so simple, actually. So you have you have storage, okay? Every unique combination of these components is an archetype. And you're like, what does that mean? What is an archetype? Well, let's say you have like a drawable graphic, right? Everything that has this, if you add like another component, for example what? For example, if you add a collider component. Also, welcome Nano Lather, thank you. Welcome for the, thank you for the 5 months. If you add like another component, collider, this is now a new archetype, okay? So every unique combination has its own storage. And this is an assumption that they make, is that you're not changing components that often. This is optimized around the fact that most of the time you're creating things that have the same set of components. If you do, you'll have to move them away to different places. But then for every unique combination of this, okay, so this is can't even talk. This is essentially like an identifier, an archetype identifier. Right, so let's say you have one that has similar components, but then let's say it doesn't have Sprite. It has Coca-Cola. It doesn't have Sprite. So then this is 0. Right, this would now be a unique archetype. Copy paste this one. I don't know I don't know how to move this stuff around. Okay, I'm gonna do this. I'm gonna go like this. Oh, you can just use the arrow keys. I didn't know that. Didn't even know. Okay, so this is a new archetype. Okay, so every unique archetype, we store a list of entities that have that archetype. So then you can be like, okay, so these, we have a table of archetypes. I'm sure everyone is following this. This will be on the exam, by the way. So you have a key value store. You go from this archetype. This is like a row or column in a table or whatever. And then you have a list of all the entities that are this archetype. So then, for example, if you have your player is here. And then you could have an enemy that's here. And then whatever. And then when you want to write a system that iterates over different components, for example, let's say here we have our component system. This thing requires, you know, everything that has a position, velocity, collider, entity, etc. You can simply get like the requested archetype. So let's say you request everything that has these, but you might request things that have fewer things. So like, let's say, you know, you don't need something to have position, but then if it does have it, it could still fulfill the query. You simply do an AND on these bit sets to get the actual the key in this table, and you look it up. And then in your system, you look this up, you iterate through every one of these values, and then you go to the next one. Let's say there's multiple archetypes. Let's say you're asking for everything that has velocity and position, right? So you have like, you know, let's say velocity is this one, position is this one, and then like these ones you don't care. This one could be a 0. Yes, it stores a list, and then all you got to do is iterate over the list. It actually stores a I guess is like a hash map of ID to what the heck is this? What the heck? You can do this in Paint. Yes. Okay, this goes here. There's a way to do it better, but I tried the different way and it doesn't seem to make a difference in Lua, at least. If this was a language that had real arrays, you could do more optimizations. So instead of storing these, you would store each component as its own array, and then that makes it really fast to iterate. I'm just storing the entity objects themselves in here. So basically, let's say you're requesting this, right? Everything that has velocity and position. Right, this is this. You cache the mapping, so you know for sure that this archetype and this archetype fulfill the criteria. So you have a cache map, and then like you go through each one of these. You simply run the function on all of these, and then okay, and then you're like, but then what if you add or remove things? Let's say you have a component and you remove the Sprite. Okay, you give it Coca-Cola instead of Sprite. So instead of Sprite, then suddenly that means that this is a 0, which means that it's no longer this archetype. So then what do? So then you take the thing that was there, you remove it from this array, and then you move it to the next archetype, the one that it actually fits into. So like, let's say, I wish it was easier to like, what is this? I wish it was easier to like demonstrate this. Here, oh god. Simply just move this to the next one. So this is now a 0. God, why are they doing it? Why would they do this to me? Microsoft Paint, can you fix your program? Alright, pretend there's a 0 here. and then you simply just move the thing from here. Let's say you find it and it's here. Then you move it here. In a language that would use real arrays, now there's a hole here, right? If you want contiguous access, you can't have a hole in your array. So in that case, you would simply move the last item into where this guy is. In Lua, I'm not doing that. I'm simply, this is just like a hash map of ID. So then I can just move it. And then now when you iterate over the system, or these components, sorry, the entities in this archetype, this will no longer be here. So then you can go through this one, and then this one. And then, you know, a lot of other stuff. It's very cool. And there's many other ways to do it. This is not the only way. There are sparse set implementations, and those also kind of work. Sparse set implementations are they're optimized for when you're adding or removing a lot of components. But I think most cases you're gonna have things that don't change that often. Welcome Delicious Smile. There's not a C API? No, it's only Lua. If there was, you could optimize stuff, but you can't. Anyway, that's the general gist of it. When am I adding microtransactions? Never. I will never. You can't either. They don't even have a payment API. How are you supposed to do that? But yeah, that's cool. Look at this. We have updating archetypes. We have updating component. All you got to do is do some bitwise logic on the component IDs. There is a way to get a component ID from a name. Oh, this is the important part. Is that in my case, your component IDs are based on their name. No, you map a name to the bit set, the specific bit mask that corresponds to it. So like velocity in this case would be like 0000. I don't know. Exactly one of these will be set. And then you simply AND these together, and then you get this one. You have to mail your coins. You have to physically send me cash. Then you have a query. A query is simply a reusable way to iterate over things that fulfill a certain number of components. And then you can use those in systems. And now you're like, what is a system and a query? Well, you think about collision, for example. You iterate over everything that has all of these components. Position, velocity, a collider component, entity, controllable. And then you want to, in this run, you can also iterate over things that have these. So you can reuse queries here. So it's like a nested loop. You check all of these, and then you check everything else that has a collider, and then you check whether they collide, and then you just do stuff. Yeah, it's very cool. And then we have a system that just works. You can spawn stuff, you could set stuff, and then I have a special thing here for there are fields that should always be available on an entity, such as the ID, a way to get the entity itself, a way to remove the components and to despawn it. These are defined as special handlers. So here, if you request an entity, we don't literally have a field called entity on this, right? It's not like this. If you ask for an entity, it'll return the exact object. So I do a special check here. So another thing that ECS engines do is that, at least the one that I was using, it would return to you the entity itself rather than the fields that you asked for. So let's say you have position, you have velocity here. One thing that was kind of annoying to me was having to do this all the time. You'd have to access the field that you want from here. And in pico-8, it's very important to minimize your token count. So every one of these adds like 1, 2, 3, 4. It would add 4 tokens. I guess this would always be there. This would be there. But you can remove 2 tokens simply by making it so that your function just accesses the fields that you ask for. So like, you know, you request position, you get a position back. And then it works, and then you just get it, and you can do stuff with it. Anyway, I learned a lot. And then, okay, what about collision systems? Hold on, let me... The first hour of this is just me not even programming. It's just me explaining stuff. Because I thought it was very cool, okay? I'm sure you're all very interested in knowing exactly what I learned last week. Archetype ECS. Okay, there's this very good article by... who? So one of these people. Archetype-based ECS. It was on medium.com. I don't remember where it was. But it was by a creator of one of the ECS libraries. Which one was it? Was it this one? No, it wasn't this one. I don't know. He went into a lot of detail, and I learned a lot from that. And then the other thing that I did was collision. Now, there's a very good ABB collision tutorial. It's available. You simply, I watched this one, but there was another one that was really good. I forget who made the video, but you could go look at it. Actually, I have it linked. Let me click on my link. Arbitrary rectangle collision detection and resolution by JavidX9. I'm sure a lot of people know about this one. You have probably watched this. If you've tried implementing this yourself, you've probably seen this video. I will not watch it on stream because it'll require me to turn off my VPN. But hey, that's me. Why am I being recommended my own video? It's because of my watch history. Well, if he's live, he's streaming game dev. Wait, this isn't the... Hold on. Am I not using a different image for this stream? Hold on. I need to change that. We have to use the hitbox one. Let me edit the stream live right now. No, it is there. Why is it using the old one? Interesting. Well, whatever. Anyway, this one explains it. So I'm going to explain it to you, okay? So that you can learn from what I've learned. So when you have two boxes that are colliding, let's see, you have two axis-aligned bounding boxes. JavidX9 is such a great resource. Yeah, his tutorials are very detailed. Welcome, Nutritious. He gives you college flashbacks that you learned this in college. So you have two boxes, right? And then you're like, oh, what do I do when the box is moving? It collides with this one. Well, I want it to move here. Or maybe if you're going here, you want it to go here, like up here instead. Basically, the way it works is that instead of doing one way to do it, which is the way that I've implemented, and also the guy from the tutorial, is that you simply you get the center point of this guy, right? Center point of this one. Is there like a better brush I can use? What's the... Okay, I just have to do this. You get like this point here. And then you get like the height and the width. Half of the height and half the width. And then you add, instead of colliding with this thing, you simply collide with an enlarged version of it. Wait, is the axis alignment just that it's not at an odd angle? Yeah, so you can't rotate the boxes. That's basically what it means. So let's say you have this, right? Then you simply would add the height to this, and you would add the width. And then instead of treating this thing as a box, you treat it as a single point. This point will be like in red. And then you simply try to calculate the time. Let's say like the velocity of this box would cause it to be here, right? We track the middle point. And then we see that if it were to move here, the box would be like... Sorry, this would be the middle point. The box would be here, which would collide. But we don't care about that. We just want to know, like, the time. Okay, so let's say... How am I going to explain this? I guess you could just watch the video. But like, let's say this is like how much it moves in 1 unit of time. You know that it collides here, assuming we're talking about the entire box itself. It would collide here. If this is 1, then this would perhaps be like 0.9 something. 0.9. And then you update the velocity so that it's less than it would be. And then you make it so that your velocity is not, you don't end up here at time 1. Instead you end up like just before this. And then the reason why you treat this as an object is that rather than finding the time this collides with this, you simply find the time that it would take for this point to be here, right? Because once the center point is here, then you know the box is going to be here. And so rather than having to like compute when this thing collides with this thing, or like this thing collides with this thing, you find when this thing collides with the expanded point of this box. And then once you have that, the time will be like the same. And it's very cool. And then you simply update your logic. And then the way this works, you simply split the, the collision into 2 components. You got the X component and the Y component. There's a very, very detailed tutorial on how to do this. I think it's actually very insightful. It uses parametric equations and a bunch of fancy stuff. It has to do like, you find the time between collisions. Like let's say you draw an infinite ray from here to where it's going. Let's say in time equals 1, you would end up here. Time equals 2, you would end up here. 0, you would be here. -1, you would be here. And then you simply find when this line intersects with the box. So like, we know it intersects here and here. But then if the box was moving the other way, let's say the box was going this way instead, it would intersect with the same points, but then they would be in reverse. Because like this would be t equals 0.1, this would be t equals, I don't know, like 1 or whatever. If you were going from this way, this would be t equals whatever, and this would be the other one. Then you have to sort them. You do the same thing in 2 dimensions, and then you simply use a bunch of logic to determine like, this is where you end up, this is where you end up, and then you just have to like adjust everything. It's very cool. I would recommend learning about it if you want to spend hours trying to figure it out. But I've implemented it. It's here. And all you have to do is intersect the ray. You have ray intersection, you have the time of intersection, right? This is the time right here. And then once you're there, you know that you've intersected with the left side. This is the normal, okay? The normal here. If you intersected with this one, the normal of the box would be x is -1, right? Y is 0. If you were to intersect this way, the normal of the intersection would be this one. And that's how you can detect whether you've like jumped on an enemy, or like you're on a platform, or like, you know, let's say there's like a Mario block. You would hit from below, you can detect stuff like that. Learn about computer graphics class in the context of ray tracing. Exactly. It basically is ray tracing. It's literally linear algebra. It's a way to speed up raycast intersection. See, Denchi knows. He knows everything. And that's why we depend on him. Is semester 1 or 2 math? Yeah, I didn't learn this in school, but now I've learned it. Isn't that cool? You learn things on your own accord outside of school. Learning math. Imagine doing math outside of school. Well, I've done it. I have in fact done math. I've done many a math. Look at all this math. You're adding, subtracting. We're doing vector addition, normalization. Resolving collisions via normals? It's crazy. No, I've done math. That's a totally different thing. Welcome, Crazy Kitty. Anyway, now that I've explained everything that I've done, I will now figure out what I'm going to learn on this stream. I'm going to figure out what systems I want to create, what it is that I want to do here. I have drawn some graphics. We have the rat from last time. We have snow. We have a snowman. and I've placed them on a map. Okay, this map is right here. Now the thing is, I am still manually creating the bounding boxes rather than detecting them from the map. So in pico-8, you can put flags on your tiles. So let's say this flag represents something you can collide with. I'm still doing it manually. I'm spawning the red the red rectangles via code. So we have look at this. We spawn an obstacle with a collider component. We give it the bounding boxes or whatever. I said, does this consider that you might have collided with something between frames? Does it? I guess it does, because it just looks at a collision rather than collision at frame times. Collide something between frames. Yes, I mean, it gives you the time at which you had collided. So like not everything is exact time intervals, because the issue with just doing the basic thing where like you increase velocity, there's a thing called tunneling, where like let's say your velocity is here and then it's here, or like your position is here, then it's here, and then next frame it's here. Then you could easily detect this and push it back. But let's say your character or object is moving fast, right? So it's over here. Next frame it's here. If you simply did that, you would not detect that it went through this object. And the reason why you calculate the time of intersection is that, let's say your vector is going like right, like you would end up. This is the line. Okay, we have too many lines here. Okay, so this is the line. It's going this way, right? Let's say in one frame you end up here, but then by solving this equation, we've determined that no matter how fast you're moving, it's just based on the direction of the vector. You know that you will have collided here or here at a given time, and then you simply determine when this time is. If this time is less than 1, then you know that you have intersected with it at some point between frames. And then since you know that this would intersect at time equals, 0.8, then you know that you have 0.2 time intervals left, and then you can simply either just stop the object, or like if you want the object to bounce off, you can say, okay, bounce it off by like how much you would have moved in 0.2 units of time. And then you could simply just adjust the velocity so that instead of going like here, you end up here. There's probably better ways to do it, like store your velocity and then like stop here and then next frame bounce back. But there's ways to do it, and I think it's cool. Anyway, so what am I doing here? So how I have it set up is that, right, I'm manually creating the colliders, and I would like to maybe this stream, instead of manually creating these, I will check the position of the rat, and then check the surrounding tiles around it, and then do collision detection on those. If it has the flag marked as this one, then you could simply create a bounding box where that thing is. And that is one thing I could do. Another thing I could try to do is implement logic so that, you know how games have like moving platforms? Let's say a platform that's moving up. When you land on the platform, you should be able to move with it. Or, you have platforms that you can jump up to from the bottom. Like, how in Super Mario, you have platforms that if you were to jump from here, you'd be able to go through it to the top. But then if you jump down from the bottom, you can't. So maybe I'll implement something like that as well. There's a lot of things to consider. It's the goal of the game for the rat to get to the cheese. What is the game called? This is just a demo. There's no... it's not really anything. Oh, when I was making this, I found this cool thing. And by found, I mean I created this cool thing to test my program. Is that I was debugging the intersection algorithm, and I had to draw the lines for where the rat is gonna go. And so I drew this line. It looks like the rat is shooting lasers. I thought that was cool. I posted this. Okay, so this is the thing I was talking about earlier. Or like we have that one line. Remember that line? This line right here? I drew that line. And then I determined at what point you would intersect with it. I didn't actually implement the collision here. But this is the same thing. You have the box here. You have the expanded rectangle around it. And then you have the center point. And then I was doing this to check that you would collide at some point. If the rat is within line of sight, it is moving toward it. And then this is one where I implemented the actual collision. The rat is here. You can fly. That's right. You can fly as a rat. You can jump off. You can then fly back up, and then you can land safely. Anyway, that is what I did. Okay, so I think I'm gonna try to implement the thing where you you create tiles to collide with, rather than me specifying the manual. I think that would be a good thing to do. I don't know how interesting it's gonna be to watch, but I'm gonna do it, okay? And you can't stop me. I guess you can stop me. Can you stop me? You can't stop me. I'm gonna do it, okay? Alright, so we have this. Stop right. I can't. I'll stop in 9 minutes though to drink water. But right now, I can't. Co-working right now. I think that's why a lot of people like watching programming streams. Is that, you know, they just need someone yapping in the background. They could be talking about stuff. Because like sometimes if the topic is too interesting, you're like incentivized to go into chat and type some stuff. But when I'm here talking about like colliders and like bounding boxes, I'm sure like most of my audience is like, I don't know what that is. What does he mean? T equals 8, T equals 0.8? What is this thing about half extents? I don't even know. And then you can simply tune out and it's just like, you know, just someone saying stuff. Whereas if I'm talking about relatable things, people are like, I don't know. I gotta go into the chat and tell him how much I disagree with him or whatever. Okay, so now we have things. Okay, another thing is also detecting what you need to count collisions with. Right? Let's say we're this rat. The naive thing to do is would simply, if we had these all as tiles, you would check collision against this one, this one, this one, this one. But we know for sure that the rat will only collide with the things around it. So there are ways such that you can create a smaller test. There's a lot of different ways. There is quad trees. Split your thing up into grids, and then if something's in the grid, consider the intersection. There's another thing called, I forget what it is. But basically, let's say this is your rat, right? How do I draw this? Let's say this is your rat. And then your rat is moving, right? It is moving here. It will eventually end up over here. Welcome, Edward, bro. You'll end up here, right? But then, like, what does this mean, huh? What does this even mean? Well, basically, let's say you have, like, other stuff around it. You have, like, an enemy over here. There's an enemy right there. Welcome, Biden Bareback. Never seen Wolfie do animated about any topic? I mean, be animated. This is so interesting. This is why I love it. But then let's say you have something here, right? You would collide with this thing. Now, the way you would normally do it, if you were a fool, you would check whether this collides with this thing, you would check whether this collides with this thing, collide with this thing. But you know for sure this is too far away. And the way you can check is you can do, you can make a smaller bounding box. So let's say you move from here to here. You simply create a temporary rectangle, and then you can do collision checks between this thing, whether this big rectangle collides with this stationary rectangle. And then you can do the more expensive computation of, like, you know, the whole like ray tracing, t equals whatever, only if it is found within this square. You can do cheap checks with AABB intersection, and then the more expensive checks, only things in here. Now, the reason why this is relevant to me is because we know the rat is going to be moving, has a velocity, it's going to end up like here or here. We can make just check the tiles around them. And that's what I'm gonna do. Remember learning about this in graphics class? You learned about this stuff. I didn't learn any of this stuff. Actually, no, I did learn some like some matrix stuff at some point. Actually, when I was in college, I learned WebGL. I think I made a WebGL game. Is it still up? Let me check. GitHub.com/Wolf's WebGL-game. Does this even work? It does. Okay, hold on. I can show you this. Copy link. This is pretty cool. So this one, I made this in college. This was not using any libraries. I simply, this was using, I used a matrix library, but I didn't use any rendering stuff. You needed to use like, whatever it's called, a lot of custom logic for implementing shading, lighting. You use matrix multiplication to like determine where to render things. There's like a near plane, a far plane to render the, what's the thing called? Billboarded sprites. And then you would write, the wiggling here is done with WebGL shaders. So like I'm not doing anything that requires like processing this in JavaScript. The wiggling is simply done by having like sine waves, and then they just do this. Looks like Minecraft. It basically is. I basically stole the graphics from Minecraft. There's like lighting sources. You can press space to have a light. You can shoot light at places. It was cool. Basically, the point is to find the exit. You're simply meant to escort this character to the exit. And it's also randomized. Welcome, Gex. Didn't do my homework for graphics class, but you should have learned. You could have learned so much. You can also zoom out. And then the levels are all different. If only I could find where the exit is. It's out here somewhere. Is this the Minecraft game? The Mince Raft game? No. This is a better game. Okay, this is the exit. And then you go to the next level, and then once you go to the level after this, also there's like a level generation. You know, the tiles are here. I have to manually, I have to do like culling or whatever it's called, so that you don't render things that are facing away from the camera. It was quite advanced. Where is that exit? Anyway, this is not pico-8. In the case anyone comes in here and you're like, what? How do you program this in pico-8? You can't, okay? There's not enough display resolution for this. But people have made 3D games in pico-8. Okay, now look at this. Now you're in like the mines. Got like the wooden walls and all that. The floor has like other stuff. Yo, look at this. How does he do it? And then later there's like a cave area. What was that sound? What's happening? Why is it making sounds? I don't know. Anyway, this is the game, okay? It is not really a game, it's more like a demo. But it was quite cool. I did learn a lot. Sorry, I did learn a lot making this, but I have forgotten all of it. If you asked me to do this now, I'd be like, I don't know. I don't remember how to do any of this. Yeah, like 4-dimensional matrices, remember that? What's it called? I don't even remember. There's like a W component. Everyone's like, oh, you got X, Y, Z, obviously. Sometimes you got W. There's 3 dimensions. No, you got the W dimension. I don't remember what the W dimension is, but it definitely existed. And at some point it was relevant. So 4th dimension time, I don't think it was. I actually don't remember what it is. X, Y, Z, W component. Yeah, what is W and why do I divide by it? It's the 4th coordinate. It is the homogeneous vertex coordinate. I don't know what that means. I'm sure at some point this made sense to me, but right now I'm like, I don't know. Anyway, that is this game. You can play that game if you want. W dimension, yo, because we're all winners. Anyway, now I can stop. I can stop for like a few seconds to simply drink some water. And now that we're an hour into the stream, we can actually do some programming, maybe. Alright. Alright, we use quaternions. Oh, I remember that. I mean, I didn't learn that in school. But I did remember when I was looking into the Bevy framework, there were quaternions. It's used for rotations, right? Welcome Eisenhower. Hello. They have quaternions. It's weird math stuff to get results to be more consistent. So true. There's byte alignment, simmed vector types. I don't actually know how it works, but I've copied things. There's a thing called slurp, right? You look at this slurp. Programmers, when they tell you I'd like to slurp that quaternion, that doesn't even make sense. What are they saying? Anyone up slurping the quaternion? Crazy. Quarter line, northern line. Object orientation is usually stored as a quaternion. Man, got rid of the W dimension. I can't believe it. Alright, let's implement the thing I was talking about. Enough yapping. Let's actually program something. But how? I've always seen position separate from rotation. As far as I know, quaternions don't do translation. I don't even know anything. Slurp this coffee? No. You can also lerp. Linear interpolation is lerp, I think. And then slurp is like, what is slurp? I don't even know. Something else. Okay, so I'm gonna make a system, okay? This system will detect collision between environment. And we're taking everything that has a... What do we want? We want a controllable. We want a position, velocity, collider. I spelled this wrong. Controllable. Controllable. Okay, so everything that has a position, a velocity, a collider, and a controllable component should collide with the environment. We can simply copy this here. Simply just then trying to paste something. Okay, so you can collide this thing. Why is this line so long? Trying to think of the word quaternions are supposed to prevent, but I'm too drunk. I don't even know. Simply don't even know. Gimbal long. Yeah, gimbal D's. Got them. Alright, so then to detect whether something has collided with the environment, you want to take the position. You want to check the tiles around it. So we have position. I'll call this pos for position, vel for velocity, collider controllable. We don't care about the controllable component, so we can simply exclude it. It's simply meant for this. Okay, so we have a function. We want delta to be passed in as well. And then what? And then we want to take the things that are around it. So we want to make a one of these axis aligned bounding boxes around the player. No, we already have that. What are we doing? We have the component. You want to find candidate tiles. We have tiles around. This is what I want to do. We're going to have position. Okay, we want to detect where it's going. Right. You want min x, min y. Wait, how do I do this? Programming on stream? That's It's absurd. This is when you have to actually remember things and explain them to people. I'm so used to not having to explain anything, just write some code and then have it not work. And then deal with the consequences. Will sigmas directly interpolate their Euler angles? I don't even know what that is. I used to know Euler. I knew enough to know that it's pronounced Euler instead of Euler. Many people don't know that. Many people think it's Euler. It's actually not. Alright, so we have position. Position.x and y. So we want to divide by 8 because we know every tile is going to be 8 pixels wide. So this will give us the tile where our character is right now. We have position.y divided by 8 as well. And then we want to know where the character is moving to. So next is equal to your current position plus velocity. And then you want to get next.x over 8, next.y over 8. So now you have things. All right, you got things. This will give you the tile that you may be on. Okay, so this, you also got to find the minimum. You got to make sure that you take the left one. Hold on, what if I just divide by 8? Position divided by 8. Oh, you gotta do this division, right? Because you gotta round it down. In pico-8 versions of Lua, integer division is backslash. Although in like actual Lua, it's like double /. I don't know why they did it this way. But it breaks all of my my IDE stuff. It's like, this is invalid, Lua. What is this? You're trying to call this thing, it's this. Also, this thing is not a thing in Lua. It only exists in pico-8. Doesn't even work. I want to learn Lua. I think it makes sense now that I've learned a bit about it. You can use it in many places. You know, you look at a meta table. You're like, what is a meta table? What even is a meta table? Like, what is this, huh? What is the $? That's not even a $. Hashtag self. It's crazy. Also, single line if statements. This is also a pico-8 specific thing. It was created so that you save tokens. What was comment? Yes, it was double dash, double hyphen. Alright, so we got this. We got this one. What do I call this? X0, Y0, X1, Y1. Yeah, Mario Kart double dash. And then what do? Well, then you gotta find tiles that are there. So then you gotta do a nested loop from but then you gotta find like the minimum. Local x0 x1 equals min of x0 x1 and min of x0 and max. And then the same for y. It's probably a better way to do this. Simply do this, and then this, and then this. Alright, so now you have the tile, okay? The tile for tile x equals x0 to x1, and then tile y. I think some engines used to do that, use 4x4 matrix in translation, vector 3 in question, or only 7 floats. Sorry, a quaternion. I don't even know. We don't even know. Alright, so now we have the tiles. Okay, these are tiles that you may intersect with. There's a function you can call, which is mget, right? What is mget? Map value at xy gives you the tile that you're on. So tile x. No, wait, hold on. Is this tile or the map value? Hold on, hold on. Pico 8 mget. Sprite number associated. Okay, it is a cell, so you do have to divide by 8, I think. Is that true? Is this even true? A cell. Okay, a cell on the map. Yes, that would be dividing by 8. So we have it correct. And then you gotta do fget. Fget gives you the flag that's present. And so we've set a thing on this flag such that we can determine things. Sounds like a slur. You can't say that, Denchi. That's not allowed. Can't believe he would even imply this. So we have set this flag. Okay, it is 0. So we know if it has flag 0 that gets set, then it must be something we can collide with. Now what are some examples? We get the flag, it is this one, it'll give you the value. So then you want to know whether, what is this? What are these comments? Hey, this is literally what we were talking about. The W component, XYZ. How did they know? Okay, you get this one. And then you must know whether it is equal. So if this thing what is this one? 0x1 is equal to this one. No, if it is greater how do you do this? If you OR these two together, it means that it is there. So then if this is simply not 0, that's what it is. If it's not 0, then you know you might be colliding with it. Possible collisions. You add this one, you add, no, I guess we could just handle it here. We don't need to, I guess the proper way to do it, if you're colliding potentially with multiple components, like multiple things on the map, is that you should sort them by time of intersection. So remember this one, we know the time that this would collide with this thing by, but let's say you have like another thing that you might collide with over here. Like I guess like over here. Okay, there's like 2 boxes. We know that this is t equals 0.8, and then this is like t equals 0.9. We sort these based on the time value, then we resolve the collision for this one first, and then we resolve the collision for this one. But in this case, I don't want to do that. It's simply too much effort. So we're simply just gonna resolve the collision in here. And also another way to do it is that rather than resolving the collision in this system itself, you just have a queue of possible collisions, and then you have a separate system that's in charge of resolving those. So rather than handling them there, all this would do is just like populate a list of stuff. And then in that case, other things can also process collisions. But in our case, I'm just going to do it in here because it's simpler. And it is just that easy. Okay, so we got tile X, tile Y. Interesting, right? We're learning so much. This is why you tune into the Wolfie streams. You're like, he's saying things, and I sort of understand. Could you put the collision detection on a different thread? Lua and pico-8 specifically. Well, pico-8 is single-threaded. In other libraries though, like Bevy, they can do these things in parallel. It can run systems in parallel. It can determine that like this system could run before this one, but then you might optimize them to run in parallel if they don't touch the same components. Welcome Shinsuo. But in our case, we just do this. We just call all the systems in our update function because it is single-threaded. We can't do like parallelization. But if you had a different system, a different engine, surely you could. Alright, so we have the tile that we might collide with. And so what do we do here? We will make a bounding box. And this bounding box specifically is going to be around the tile, okay? So here is our current situation, okay? We have the floor. Each one of these floor tiles is like this. We're gonna copy this. In there. Okay, then we have our rat. Our rat is gonna be moving around. The rat has its own bounding box. So let's say that the rat is here on this frame. And then due to gravity, the rat would end up here on the next frame, right? We have this arrow. Rat would end up here. Now we want to detect the collision and have the rat move over here instead. And now we have, what we've done here is we have drawn tiles, okay? The tile detection thing that I've done is going to detect these tiles in blue right here. It'll consider anything that's like within these, right? Then it'll do collision detection against these two. And the way that you do that is similar to the other systems we did. We take the bounding box of this guy, we expand it out a little bit more based on half of the width and half of the height of this guy. And then we compute a ray from the center of this guy down to this one. And then we try to see when this point right here intersects with this box. So we want this to be here. Once we've calculated that, we will simply move this guy, adjust the guy's velocity so that it goes here, right? This is now the new center point or whatever. And I'm sure all of that made sense to you. I've explained this several times now. Obviously, that's how you learn things, by explaining. Welcome home, M. Sinica. That is not an emote that exists. Alright, so okay, now that I've explained what to do, we will take the bounding box of the thing that's moving. We've already done a similar thing up here, so I'm going to copy this. So we have this guy right here. Actually, I guess one reason to have a list of things and then process the list later is that you can avoid creating the collider if there's no detections. You can simply return early if this is empty. So I guess maybe I will do that. Do I want to do that? Yeah, okay. Local, hold on, we're gonna do possible collisions. Have it be an empty thing. And then add possible collisions. So what do we add here? We want to add X and Y tile of the thing, or we could compute the bounding box and put it in here. I'm just going to pass it the X and Y. No, you know what? Let's just not do that. This is gonna be, it's gonna be more tokens. I've already convinced myself not to do it. We're just gonna do it in here. So we're always gonna calculate the moving collider. No, but then like we're gonna calculate this every frame for no reason. Okay, so I've convinced myself the other way around that we are going to do this. Classic streamer moment where we do this and then we don't do it. Okay, so we have possible collisions. We add to it, maybe we'll just add X and Y. Tile X, tile Y. Alright. And then now that we have this, the many but wait, what if we did it this way? What if instead of doing it this way, we did it this way? Okay, so if possible collisions is empty. Is there like a way to do this besides doing it this way? This will get you the length of the array. And by array I mean table. If there's nothing there, you just return. Otherwise, you go through all possible collisions. In all possible collisions. So then we have our moving collider, which is going to be the rat. We will offset the collider because the collider is defined relative to the center point of the rat. You'll see here that we define the collider as this thing, but we're not changing this. When the rat moves around, the collider has the same bounding box indexes. We simply translate this thing relative to the position of the player. So we're going to do the same thing here. We do collider offset position, and then we have the position of the collider in, what's it called, global space or whatever. What is it called? What does Bevy call it? Also, thank you EKR for the subscription. Global transform. I think that's what it is. Yeah, global transform. The global transform is where the thing is in the entire world space. And then the regular transform is relative to its parent. Alright, so we have possible collision in all possible collisions. We will create a bounding box relative to that tile. So how do we do this? Static collider. We want to center it on where the tile is, the middle of where the tile is. So how do you do that? Well, how do we define our axis aligned bounding box? We have a center. No, hold on. I can calculate this based on... Okay, min-max might make more sense. AABB from min-max. We can set this as just like a regular one that's not offset. Axis line bounding box for min-max. You would set this to... So the minimum would be at 0. This is relative to the tile itself. So if you'll remember, a tile in Bevy, sorry, not in Bevy, in pico-8, is defined from this point is 0. This point is 0, 0. This point would be... Would this be 8, 8 or 7, 7? I guess you could... The width and height are 8, so I guess this would be 7, right? Maybe? I don't know. I guess we'll find out. I think it is 7. But you would need to multiply by 8. Anyway. We have this. We have the other point would be a vec2 of... I guess it would be 7. 7, 7. So this is the static collider. Like this. And then you would simply... You would shrimply just do this correctly. So this is here. And then once you have the possible collisions... Oh, you also want to expand this. You want to expand this based on the original collider. What do I do? Expanded. Expanded. I guess I do it here. Hold on. Static expand. I guess I could. Yeah, I could have this extracted out. Do I want that? Do I want that? I guess for now I can leave it there. Performance is not too much of an issue yet. So we have this. We have AABB for min-max. And then in all possible collisions. Okay, now we have our static collider, our moving collider. We want to do the same logic that we had earlier. This one right here. I guess I'll just copy this. We also want the entity to be returned. So we have, whoops. Entity is here. And then what? All possible collision in all possible collision. Oh, you would have to offset this. So the static collider would be offset by, what is this? Obstacle collider. Obstacle collider would be offset by the tile position. So all possible collision. Where is the tile position? We would need to multiply this by 8 again. Hold on. I guess we'll do, yeah, this will, instead of returning this, it'll be a vec2. A vec2. A vec2 of tile x times 8, tile y times 8. Okay, so this is possible collisions. It'll be obstacle collider offset by possible collision. Sorry, instead of being named possible collision, I'll name this tile, I don't know, tile min. Okay, so now we have this obstacle collider. I'll name this static collider. Alright, and then if it does collide, we'll simply resolve the intersection. And then I need to actually call this collide environment. We'll do this before this. Oh, okay, let's see if this works. It does not work. Okay, line 108. Should use equal for equal. Oh, it's like this. And then what? And then APB Lua line 2. I try to add index local B, a nil value. Did I pass something wrong here? We add possible collisions to this tile x, tile y. Possible collisions is equal to 0, and that means there's nothing there, and you return. And then if it's not there, you're guaranteed that you might collide with something. And then you iterate through all of these. Tile min, tile y, tile x. What did I do here? What if I debug? If I were to simply debug this. This is a custom helper that I added. Debug, I added some helping functions here. By default, if you try to print a table in Lua, it'll just print out table. It's kind of, I know people in JavaScript are familiar when you're trying to debug an object, it just prints out like object or whatever. The same thing happens with Lua. So you have to write your custom helper function to actually like convert it into something readable. And then I added this custom debug helper to make it easier to call this function on stuff, and then also write it to a log file. By default, it will not do anything. It will simply show it to the console. But then if you didn't run pico-8 from the console, then you can't see the logs. It'll try to print it to the screen like this, but then if in cases where you're like drawing over it, obviously then you can't see the logs. So my custom debug helper is going to tell us. And then I simply can just, what is this even the right directory? There we go. Alright, so let's run this again. And then we try to see if we've logged anything. We have not logged anything, which means that we don't even get to this. What are we doing? Debug. Got here. And we run it. We don't have it. Is it not logging? What's happening? Did I run? Oh, okay, does it only work if you run it from the directory? Is it there? Where is it being logged to? Is it not even getting here? Oh no, it is getting there. Wait. Where's my logs? Oh, it's over there. Okay. Tail minus F. Pico log. Alright, so now we'll have logs show up. I try to run it. It is not running. It's not getting there? Did I remove the line? What? Where is it? Where's my log statement? Oh, wait. Why is it not working? It's not showing it in real time. Is it because this thing's on a Windows file system? And try to tail-F from Windows subsystem for Linux? It doesn't do it. Is it not actually watching the file properly? Man. Can't believe this. Alright, well, surely there's a better way to do this. Is there a better way to do this? We want to check where this is breaking. So it happens when we're trying to add two vectors. Where do I do a plus? We try to add position plus velocity. Oh, because I named it vel instead of velocity. Classic programmer mistake, trying to abbreviate stuff. Okay. So obviously what I had there did not work, because it did not detect collision with this tile. Now what's happening here? Wait. Hold on. What's going on up here? Hold on. Did I forget to divide by 8 somewhere? Did I forget to like multiply by 8? So I've detected the tile down here. But maybe... what have I done here? For tile x equals x to x1 from y0 to y1, if you get the tile x, tile y, and it has collidable, you add to possible collisions, you multiply back by 8 to get the real coordinate. And then you have your static collider. The minimum would be starting from the top left of the tile. Maybe I should just draw some stuff. Let's draw... I did add custom helpers to help me draw stuff. So let's do local offset collider. Put that there. We have offset collider. Static collider in the event right before your static array group falls apart. What is bro talking about? Final Fantasy. Offset collider.draw. Sorry, colon draw. If you're wondering what this is basically syntactic sugar for passing self as an argument. This would be the same as doing this. And this is useful when you're defining metatables, because typically you would have things like, you know, a function, whatever. But then this would be defined every single time on your object, whereas you can define a metatable instead, where you do metatable equals this, and then you have your function in here. And then instead of doing that, you simply set metatable of a new object, and then you give it the metatable. And then now, since this doesn't have access to self, you would have to pass it as an argument. Right, this is classic Lua behavior, passing self as an argument. Alright, so we're drawing this. We're going to try to draw this every frame to see what we're trying to collide with. Does not work, simply because I think I'm overriding it somewhere. Is it drawing this? Hold on. Offset collider draw. We should try to draw everything that we are colliding with. In all possible collisions. So we are here. We are over here. What does that mean? What am I doing wrong here? mget. We get the map value at xy. I'm going to assume that is the tile coordinate, and then you get this sprite number n. We have a sprite return from this. Debug possible collision. Okay, it is debugging. It is debugging many frames. It is lagging. We have many possible collisions. The question is, why is that happening? We are colliding with several things. So we have position x divided by 8. Oh, is it because we are... Hold on. I'm trying to get this. Are we... We're not even... Okay, hold on. Possible collisions next is equal to position plus velocity. So we're here. We're going to go here next. And then we calculate position x divided by 8. That gets you the tile that the user currently is in. Position y, next x, next y. And then we do this. Oh, hold on. I did this wrong. Whoops. I simply... This should be y. Sorry, I'm failing to do this. Failing to apply logic here. When the guy thinks he knows Vim, but he doesn't. Alright, change the x into y. Alright, I think, it said may, look at this. When you do string replace and it replaces stuff you don't want, replace it with may. Okay, I think this should work. Nope, it does not work. Something else is broken here. It is colliding with something. I'm not sure what is happening here. Something is definitely happening, but it's not what I want. Alright, so we get x0, y0, y1. We get min, max, min, max. Okay. We get tile x, tile y. From y0 to y1. Then we get the tile. If it is this, and it is not equal to 0, that means that it is possibly colliding. Then we get the tile x, tile y, multiply that by 8. Possible collisions is 0, then do nothing. Why is it not drawing my collider though? Oh, it's because because I'm clearing the screen here. Okay, I will instead put this here for debugging. Okay, here we go. All right, look at this. There, okay, we got possible collisions are being drawn. I should draw this in a different color. What color should this be? Possible collisions, let's draw that in gray. This is color number 6. Draw. Offset collider, draw 6. Okay, so based on the velocity of the guy, it is saying that you might collide with these. If you're moving this way, you might collide with these components, and then this is what you're checking. That's kind of cool. Okay, so obviously I think we're checking too much. Why is this thing being collided with? Is this saying that we are inside a box all the time? That we're constantly colliding with the box? Every single one of these we appear to be colliding with. Okay, if we have collided with it, I should show it in green. Draw this one in color 3. Okay, so it thinks we have collided with these for some reason, even though that tile is not marked. Hold on, did I mark it incorrectly as something? This doesn't have this thing defined, right? That's fine. Did I draw this? Was this supposed to be? Okay, that is the snow tile. Hold on. What tile is this? What tile is that? Is that the blank tile? What is this? Okay, this one. This is the tile that we're using for snow. But I'm assuming, wait, why is this the same? When you right click, you copy it. But then when I'm drawing, it doesn't. Why is this one not being drawn? Is this tile special? Okay, I'm gonna copy this here instead. Let's delete this one. Let's change our snow tile to use, what was it? Sprite number 3. We have our snow tile is here. Snow tile, where's our snow? Snow tile is here. Sprite should use index 3. 0, 1, 2, 3, okay. So we get this one. If we do an OR with this, then it has the flag. Then we add to possible collisions. Why is that? Why is that? There should not be. It should not be that. What does this return? Gets the final value of the flag. Hold on. Flag index is omitted on bit field. Wait, no, that's what I wanted. Okay, we can just test for something, right? Hold on. Oh, if we pass, okay, I see. If we pass it the argument of the flag we want, it'll return a boolean. So instead of needing to do this, we can simply do comma 1. Right? What is it? Comma 1. This is flag number. Okay, it's flag number 0. Okay, let's make that flag number 0. Now let's check if that works. Yo, guys. Okay, that was not supposed to happen, but like we got something kind of working here. Look at this. You can walk on the tiles, and then for some reason you fall through them, but it's kind of strange. Okay, so then hypothetically, if I were to add other tiles to the map, we should be able to jump on those. Yo, oh my god, we got... Okay, so like something here is clearly wrong. The fact that when we walk a bit too much, we end up falling through the tile. But otherwise, it kind of... Oh, and then you fall through, then you're on the bottom and you can't go back. Hey, but now you can go back. Well, something is definitely broken. But I think maybe it's because I'm also checking for intersection with my other thing. The other collisions that are happening. Yeah, okay. Nope, that's not it. Hold on, is that it? It's because when I walk off this edge. No, it's not. Clearly something. Oh, I think it's because... No, because I set it to be 7. It should be 8. I think there's like gaps between the tiles that we can fall through. Let's make this 8 instead. Okay, no, that's not what it is. It is something else. A rounding error. I think this is pretty cool though. The fact that you can like see what tiles you're testing collision with visually. And like things that you might intersect with. Like, look at that. It's like, oh, you might intersect with these, so I'm going to check these. Oh wait, no, hold on. Is it because I'm doing velocity? I should be multiplying by delta. I'm not considering delta anywhere here. No, we are. We're pressing delta. Oh no, it's here. Velocity, we should be, yeah, velocity times delta here. Because we're considering how much you can move in 1 second, whereas we need to constrain it a bit. Okay, see, now there's less candidates to check. It's only the tile that's directly below you. Okay, but then why is it that we can jump through this? So we're considered not in collision with this tile for some reason. Oh, it's because we're inside the tile. Oh, we should also consider the tiles that are above you. If you're moving upward, it's like because you're within this tile. So then the collision detection only detects when you're outside of it. Which sometimes is what we want. Sometimes you do want like platforms that are like this. But I think in our case we don't want that. So like if the player is below the tile, we should just add that to our search as well. But shouldn't the velocity handle that? I don't know, but this is cool though. Look at this. We got collision working. We can define platforms on which to fall onto. Wow. Okay, let's commit this. We have this one. Okay, let's move some stuff back. Let's move this. What was it? What did I have here? What did I change? Oh, I moved this. This was here. Okay. No, I should keep it. I'm gonna be continually debugging this. Okay, so we got this one. We got collision. I should uncomment this thing to check that it doesn't break. Okay, so we can still collide with our existing colliders and also tiles on the map. Very cool. Let's commit. Add collision with tiles. Map tiles. Alright. Now we gotta determine why we're allowed to jump through these tiles. Is it because it's because when we're doing the rounding, right? Maybe I should not do this. We should not do truncating division. No, okay, if we don't do truncating division, it breaks. So we get this one. Should we also always check the tile to the left? I don't know. Position divided by 8. And then what? And then what? Any programmers know what I did wrong here? You're like, actually, Wolfie, this is a common problem when you're programming collision systems, specifically around tiles, is that sometimes when you're within the tile, it doesn't work. Should this not be handled, though, by our upward velocity? Is this not already a thing? Can fall down here, and it will still work. But sometimes it doesn't work. Sometimes you can just fly right through this thing, and I don't understand why. Why is that? Do you do something for the sake of inclusion-exclusion from the search set? Inclusion would simply be if you get the tile. If the tile is there, welcome NanoDan. It is cool, right? Look at this. Collision systems. Very cool. Hold on, but it is detecting when we are within the tile. It is detecting this. It's like right before we hit the tile, it doesn't detect it. We should be detecting it before we hit the tile. I've yawned for the first time in literal months. Wow. Glad to know my stream is so boring as always. I know that's not what you implied. I just like to be adversarial. Can't believe this guy. He's yawning at my stream. Get him out of here. Alright, we got the collider. We got the moving offset. We got possible collisions. We have the tile. the tile that you're on, from x0 to x1. Position x, position plus velocity times delta. Position, you're currently here, and then you check where you're going to be. If where you're going to be is less than this, then we do not check. But maybe we should. Hold on. Position plus velocity times delta. I wish I had kept my logic that was there earlier. Wait, can I? Hold on, I can keep it. The bit sets, we got the debug. Let's see, in here, I just have to like add a line, right? When I'm checking for collision, in the sweep function, we check for velocity. You can draw a line from the center. Is that a thing? Check whether the ray intersects. The ray origin is this. So when we check for intersection, I can draw a line from ray origin dot x, ray origin dot y, and then x1, x2, this would be ray origin dot x plus ray direction dot x, ray origin dot y plus ray direction dot y. Oh, but that value is so small though. Hold on. Ray origin x. We could multiply this by, I don't know, 50. Okay, so this will tell us, this will tell you, whoa, what the heck, look at this. This will tell you where you're moving toward. This rat is shooting a laser. Welcome, Raiders. Hello, Adam Learns Live. I'm gonna assume that you were programming. Let me shout you out. Adam Learns Live. Welcome, Kevin, as well. I knew it. Software and game dev. Welcome, Kappa Jabated. What were you programming? Were you also doing video games? I'm trying to code a collision system with tiles here. And we are drawing a vector showing where this rat is gonna go. Looked at spreadsheets for 7 hours. He doesn't make games. I'm gonna assume that sometimes you make games though. And that is why you're doing games too. I use Google Sheets as my game engine. What the? Are you programming? You're putting tiles in there. Welcome L:Q. Hello. That is another programmer who sometimes makes games. Anyway, we're making a pico-8 system. Making collision detection. For some reason, it's not working. See, it works when we fall onto it, but when we try to jump through it, like, it's not detecting this collision. And I need to figure out why that is. Pico-8, I was a bigger fan of Pico-7. Why was Pico-6 afraid of Pico-7? Am I right, guys? Because Pico-789. Haha. Hilarious. Streamer, this is so funny. This is why we're gonna follow you right now. Pico-8 is cool. It has a bunch of code limitations. Yeah, it's got token limits. You are allowed a maximum of about 8,000 tokens. And a token is defined as any keyword. It does not count closing parentheses or end or commas or dots. But there's many things that you can do in a low, is it called, low token count? There's also a character count, which is not really a big deal. You can also edit a map in this thing. You can make sprites. You can make music. I've not done music yet, but you could do it. And earlier this stream, I described an entity component system that I made. We have this library where we simply define systems that we want to run. it'll get all the entities that have these components, and then you can run calculations and other stuff. And it's cool. Yeah, you can do music. Can you believe that? He's funnier than you. I'm so funny, guys. You don't even know. Also, welcome Renegade Pidge. Anyway, we're coding some stuff. Okay, these are our systems. We have input handling. We have animations. We have vectors. Okay, so one interesting thing here to note is that the rat is moving downward constantly. Look at that vector, that gray. Wait, what is that gray line? What is that? Oh, are we testing collision between two? Okay, we have two collision detection systems. One is for tiles and one is for these things right here. And I'm gonna assume that is drawing it for both of them. Because you are on this tile, and you're also possibly colliding with this red thing. Can I explain what I'm doing in League of Legends terms? I've never played League of Legends, and I never will. But you know, what if you're like in mid, and then someone tries to gank your mobs, and then they're feeding, and then like you tell them to go top lane, but then they don't, and then they go to jungle instead. I'm sure that meant something to someone. I'm just saying words, I don't actually know what it means. What if you were at bot lane? Bot lane, guys, bot lane. I don't know what I'm saying. Anyway, we're here. Of course, they're feeding. Alright, so I think if I just like tried to subtract 1, you think that would do it? Do you think that would be something? Is this anything? Okay, that is something. But like ideally we don't have to do that. Something is wrong about that we should not be doing this. You have someone intings, you gotta rotate to cover the inting of mid laner. Sure. I'm sure that means something to someone. But not me. Alright, so this is wrong. It works, but it's wrong. And I don't know why. Why is this wrong? Tile X. If we do this, what if we do this? So like, even though we're not moving, it is trying to test the tile above us. Which means we're doing a lot of unnecessary checks every frame. But like, why does this not work? Why is this not being detected? Oh, what if I put render, hold on. If I go here, and I don't multiply by 50. If I keep this here, but then I do the rendering before, so that our rectangles are drawn above. Okay, so we have the rat vector. This vector that you see in the middle of the rat is where the rat is moving toward. You'll see when the rat falls from a high distance, you'll see that vector. Oh look, it's even drawn the little rectangle. You'll see that downward vector is there. And when we go up, that's where we're checking. Did I hit the token limit? No, I'm nowhere near it. I'm at about 2,000-ish, which is surprising. I thought it would take more tokens to implement an ECS library, but actually it's not that much. It's actually nothing. And also collision. I think total, if I remove all of this code from my main and then see how much that takes, it's like 1,000. But then I also have like other stuff. Hold on, I could simply do it in here. If I exclude my debug stuff and exclude main, hold on, it does not save it. How do I? I guess I have to do it in the pico-8 editor. Yeah, if I comment these out. And then 915 tokens. So only 915 for an entire AABB implementation and entire ECS thing. It counts as a token. Keywords, parentheses, but not closing parentheses. Commas don't count. Equals do count. Local doesn't count. End doesn't count. These things count. So like for this line, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That would be 15 tokens right here. Alright, so let's go back. Let us bring these back. We don't need this. Is function a keyword? Yes, but it's also a token. Keywords are tokens. This is in the context of like parsing. That every token here. That is it. Some tweet cards. Yeah, people can do some impressive stuff in like 200 characters. Not me though. I can't do it. I would never. Alright, so what are we doing here? What am I doing wrong? In general. Am I not, hold on, am I not extending the radius? No, that's fine. I am extending it. I have in fact extended the collider. Should I also show the extended collider? Hold on, so we're here. Moving collider. Avoid collisions. Where is it? This one. I'm drawing it here. Collider offset. Oh, because I'm doing... Hold on. I'm expanding it in here, though. Where is it? Sorry, it's in here. I expand the collider in the sweep function. Maybe I should draw this one here. Static expanded dynamic. Let's do this one. Let's draw this one in color number 10. Okay, so we see the expanded colliders. This is what we're checking our collision against. See, now this one doesn't get triggered until we're like already in it. Oh, is that what it is? I need to... Hold on. It's because the I need to consider the expanded collider in my search. So I should... Let's see, what should I do here? I think that's what it is. Instead of doing... let's see, instead of doing this, I should also increase... Wait, what am I doing? What did I just determine? Also, I should drink water. It is 7 p.m. You should also hydrate if you want. Alright, so let's see here. Get possible collisions. Tile X times 8. Tile X times Y. So this will give you the top corner, the top left corner of the box we were about to collide with. Did I welcome Hamflow? Was that your first message today? I don't even remember. It wasn't. You were here. And I just forgot. Streamer forgets his chatters. Can you believe that he forgot that Hamflow was here? Alright. So we are not checking collision for all the tiles. So we have the lower position, the delta, Position delta. I should also draw another box. X0, X1, Y0. Okay, what does it require? Y rect. Okay, Y0. And X1 and Y1. And we should draw this in the color known as 12. Everyone's favorite color, 12. Why is color 12 not being drawn? Excuse me. Color 12. Rectangle. X0, Y0, X1, Y1. What? Oh, because it's divided by 8. You should multiply this by 8 then. This is simply a temporary measure. Okay, well, something is strange about this. Is that it is rendering something. But only sometimes. Oh, it's the tile that's behind us. Wait, why is it not rendering the other tile? Hold on. Get the current position and the next position. And yet it's only rendering one tile? You got too much stuff on the screen. So thanks for stopping by. Feel free. Yeah, you can go get some food. You can also sleep, or whatever it is people do. What do people even do? Sleeping? Eating? Scrolling? Doom scrolling? You could do some doom scrolling. So why is this not going there? This is here. This is there. But it's not going the other one. We divided it by 8. We have the next x divided by 8. Oh, that's what it... Hold on. For the next x, we should be... Instead of this one, we should be... Hold on. We should be... We should do floor and ceiling on some of these. So this one should be... What are we doing? We should divide all these by 8. And then what? And then once we've determined, we should be doing floor on these. And then we should be doing ceiling. No, we should be doing ceiling on this one. Wait, no, floor on this one, ceiling on this one. I think that's what it is. So we got position divided by 8. Hold on, guys. I'm gonna redefine these. We'll do tile. Actually, hold on. We should do position divided by 8. And then... Wait a second. Guys, wait a second. We have the next position. So I'm rounding too soon. So we have this one. We have x0, xy. I think I should define these in the same order to be a bit less confusing. So this should be y0. And this one should then be max. Alright, so we have this. And then for the minimum one, we should be taking the floor. And then for the maximum one, we should take the ceiling. And I think that should possibly work. Nope, it doesn't. It does not work. But now it is, I think it is now searching. Wait, it's not working. Did I do it the other way around? We should be taking the ceiling of this one and the floor of this one. Is that what it, no, that's not what am I doing? Maximum, we got x0, y0. Like on the left side. We should be taking the floor of this one. And then the ceiling of the next one. But why? But why would he do that? Can we answer why this guy's doing this? No one really knows. Okay, so when you're static, it's only because you're not, okay, you were searching your current position. Okay, this one, no, it's broken. This is worse, actually. Why is this worse? This is so confused. See, look at that. You see that? What is that? Why is it doing that? This is worse. I've somehow made it worse. Alright, so we still got this one. You know you could do this. Earlier, 1 minute in Vim. If you mess up your undo history, you can simply go undo in temporal. Just undo temporally. But that's wrong. That's right. Okay, so we have this. Isn't that amazing? It's good to know. It is good to know. So okay, I undid too far. We have this one. We have that one. This is min. This is max. This should be also min. And this should be max. Okay, I messed something up here. Okay, this one divide. Oh, it should be floor dividing. Why is this wrong? This is me the entirety of yesterday. When I was trying to debug why this thing wasn't working, I was just like going through all the lines and being like, why doesn't this work? I thought this was supposed to work. They told me game dev would be fun. Actually, no one said that. Literally no one has told me that game dev would be fun. In fact, possibly quite the opposite. But it is fun. It is fun. There's just some times when it's like, why is this not working? Why is this not working, guys? Alright, we got tile position. Okay, obviously the position of the tile, as you all know. Tiled positioning. But why? This rectangle. This rectangle is not correct. Oh, because this should be x1. But it's still wrong. x0, y0, x1, y1. Min of x0, x1, y0, y1, x0. So that's there, right? That is there. xy, next x, next y. You get the collider. The collider is not even being tested. Why would he not test the collider? Doesn't he even know? Does he not understand? Alright, so we have these. x0. We got this one. Position. What if instead of doing this, simply just do, no, this is fine. Times 8. This is multiplied by 8. And then you have this. And then you have that. And then you got this one as well. And obviously, gotta have this one. Everyone knows that this is always a thing that you gotta have. And no one even questions. Do you see that? We like clipped through this thing? Even when going downward? Is it that our tile detection is wrong? This shouldn't happen. Oh, because when we're on this tile, hold on. We are not detecting something. Something is not being detected. Question is what? I just don't know. So it should also happen. Okay, it also happens on this side. Quite strange. Like once we're past the halfway point, like once the center of the rat is past the edge of the platform, it falls off. And so how should we adjust our collider for this? So this one is here. And then what? We should be checking. Wonder if anyone, surely someone has encountered this. If I search here, AABB, ray, collision, tile. Tiles, any tiles? Tile, hold on. Here we go. Array-based tile maps and bounding box, how to do collisions. What is their logic here? Is colliding. You have your character, you have int. You have their position. And then you go from your current position to the right bounds, and then you increment by tile width, and then you check what. Reason there isn't a standard AABB or partition strategy for tile-based maps is that it's already easier to detect collisions against it than using AABB. I don't see a problem having this for your tiles. Thinking of this, what? Welcome, props not Jack. Is this overkill? Using no, because then we gotta, because like if you're falling through it, you still gotta count on the normals. How do you do it though? How do you even do it, man? We got the ray intersections. Got the branchless. We got this thing. We got array-based tiles. Intersection tests in 2D. No. Not at all. Most efficient canonical way to do this detection against the ground. I feel like I've definitely read this thread when I was debugging yesterday. What if I require the word tile to be in here? Tile-based map. Tile-based collision techniques. Tile-based collision. What is this? I'm not reading that. Imagine reading that. I'm not reading that. Tile-based collision detection and response. Is this what I want? This is it's not in German. What are they talking about? Just because the title is German. Is that even German? Collision resolution, right? You got this thing. Collision resolution with rectangular objects. Oh, it is in German. Wait, what? Alright, I guess they were right. It is in fact a German website. Ray, okay, is this what I want? Ray to tile map collision. What the heck is this? Digital differential analyzer? Is that what I want? GameMaker has something. Digital differentiate. GML implementation? What are you talking about? Length around, current distance, tile size. Boolean indicating if tile was hit. Tile raycast. Tile found, current distance, map check, tile size, step -1, x divided by tile. Okay, hold on, this is similar to what I want. Compute ray step size in each direction in tiles. 2 is 2 tiles, not 2 pixels. Ray step size. Should we be taking the ceiling? Oh, I think wait, maybe that's what I want. Maybe this thing right here, the next position should be a multiple of 8 at least if we're moving. Right? Is that true? Velocity is 8. I think we're not scaling this enough. Velocity times delta. So this should be at minimum 8. If this is any less than 8, we should make it 8. Unless velocity is 0. Velocity times delta should be at least 8. But don't we handle that with this though? Next x divided by 8. Should we be doing this? This should be ceiling. Is this what we want? I think maybe this is what we want. Is that true? No, that's not true. Is that true? No, because we want the so we want this. The absolute value should be, well, I don't know, let's just try this. It's definitely not going to work. It doesn't. We've confirmed that it doesn't work. However, we know that velocity and delta, this should be rounded up. So let's see. Local delta, was it rounded velocity equals to, velocity could be negative. So we should make sure that we round in a positive, in a way. Is there a word for this? Like if it's negative, you should round it upward. Is that even a thing? Hold on. Let's just install Lua for real. Round towards 0. No, you want to round away from 0. Yeah, round away. What is that called? Is there a word for that? Yeah, let's add a real Lua. Lua 5_3. Round away from 0. How to round away from 0? NumPy? This is not NumPy. Come on, guys. Round toward away from 0. Is there like an operation for this? Is this even a thing? +1 and then round down? Is he right? Is he right? Does he know math? Surely he knows math. This has got to be correct then. I'm going to trust that Denchi knows what he's talking about. Let's do an example here. So we have 1.1. We should add 1 and then floor. That gives you 2, which is what we want. If it's negative, it gives you -1, which is not what I want. I want this to be -2. So, I mean, you would... No, that doesn't work. How do you do it? Math floor? Math ceiling? It's not even right. What the heck, man? How do you even do it? How to round away from 0. How to round away from 0. Symmetric rounding. Is that a thing? Programming? I should specify programming. A ternary? No, but that uses tokens. Don't you know I have a token limit? Round is a built-in library. Wait, is that a thing? Hold on. Pico-8 round. No, there's floor, there's ceiling, but there's no round. Math. See also math. That's not even real. Fine. Guess I'll do it. I guess I'll have to do it. Alright, so if okay, so let's see here. But then it's also like each direction could be positive or negative, dude. Man. What if we get the absolute value and then... No, that's too much. Surely there's a better way to do this. How does this guy do it? We were literally reading this article. Square root. What? Ray length. Normal. Use the ternary. There's no ternaries. I would have to do this in 3 places. I guess there are ternaries. You could do this and this or this. Alright, fine. So we have, but then you'd have to do it for each component of the vector as well. Okay, so we got local next equals to positive, so position plus velocity. So velocity times delta. And then this is what you want to round. So next dot x equals to next dot x is greater than, if it is greater than 0, then you would simply ceiling. Otherwise, floor. And then you do the same thing for y. And then possible collisions is here. Man, look at this. There's like, look at all these tokens. That's at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's at least 30 tokens right there. A new function? I can't believe this. Okay, this is too much. What did I do here? Welcome Hamp. Something is definitely wrong. If next y is greater than 0... Oh, I still need to add it. Right. Next is equal to... Right, I still need to add position to this. So next, what do I, naming variables? Next, I don't know, whatever. And then local next equals position plus next delta. Nope, something's wrong. Next delta, oh right, because of this. Oh, what am I doing? It still, it doesn't, it doesn't solve it. Hold on, is this logic correct? If it is greater than 0, ceiling. Otherwise, no, we should round it, right? We should still round it to the nearest 8. That's the entire point of doing this. We should ceiling, but then should be multiplied by 8. And then we should... Hold on, what is the math here? If delta is greater than 0, you should do ceiling... It's not even ceiling, it's rounded to the nearest 8. So we need to like divide... What are we doing? We should divide by 8 here. And then multiply by 8 afterward. Right? Oh god. Is that? Oh, that is it. Okay, so that is in fact... Well, I did something else wrong. For some reason, the collision, we are falling through. And I think the reason for that is that we have to sort them. We have to sort them by distance away from us. We have to resolve the collision of those before the other ones. And it may also be because our velocity is different. We get the tile, we update our velocity, and then what? And then what? Or maybe it's because this thing should be 8. Nope, it still happens. Okay, well this does solve the issue of jumping from underneath it, which is good. That is what we want. Wait, but how did that happen? Do you see that? How do we do that? Okay, we gotta fix whatever that is. That's definitely very broken. When we move rightward... Oh, they talked about this exact thing in that other video that I watched. The other guy, what was his name? What did I search today? That one. The video that I did not watch on stream because I needed to log in. He also talked about this. It's because we are resolving the collisions in order of... in one way. We should be sorting the array before resolving. Sort them by distance away from us. And then what? So then we should be storing collision time, sorting everything by this. I guess we could just detect the distance, because like these things are not moving. We just detect the ones that are farthest from us and do those last. I mean, but we're already calculating collision time, so we might as well. Let's see. Hold on, but does this solve the issue where... No, it doesn't. Wait, what? Do you see that? Why could we still do that? Why is this? See, like when you do this, it doesn't happen. But then when you jump underneath it, wait, sometimes it happens. See, like this one, it's not handling this. Oh, it's because our horizontal velocity is 0, and so it's not checking that. I think okay, no, hold on. Rather than doing this on this, we should also be checking the tile, even if our velocity is 0. We should be checking, well, is that true? Yes, I think it is true. We should still be checking some tiles. Because like this, we don't handle this. But let's see, we got the delta. There's gotta be a way to do this better. Like, what is the strat here? What is the meta for this? Did you know that they balance things in pico-8? Were you aware of this? You know, like in games, they're like, this character is too overpowered. In pico-8, there's like some things where like, hey, by the way, do you know that unpack doesn't count as an operation, and so you can have as many unpack operations as you can, and it won't affect your runtime cost, even though it costs more to run on the system. And then the developer was like, oh, this shouldn't happen. We should make unpack cost some CPU. They do have balance patches. I thought that was funny. It was specifically when they were talking about sorting things. Here we go. I'm going to find the thread and show you the balance patch that was issued. Look at this. Fast sort function. And then it says unpack. To any computer scientist, this would be badly written and perform extremely poorly, because unpack copies the whole array n times. But in pico-8, this function is fast. This virtual CPU instruction is free. And then the developer was like, we didn't consider costing the unpack. We need to balance it at 2 cycles per item. Like, wouldn't that kill usage of unpack? I can't believe that you would destroy unpack. And then this is where I got the idea from, is that we're talking about balancing a game engine instead of a game. I think that was funny. Classic. Alright, so what are we doing here? Well, let's see. If our position is not what? If our the boxes, okay, the boxes, we should be considering positions. Maybe I don't need this. Maybe like this is not even necessary. I think that perhaps what I should do, I will comment this out. We got next, we got velocity, we got position plus velocity times delta. This will give you your next position. Now you should always be checking the tile before and after where you currently are. What does that mean? What does that mean specifically? Well, it's simple, really. It is actually so simple that I should be checking against the moving collider. I think that's what the issue is that the moving collider, it's because the position of the rat is simply... Oh, is that what it is? The position of the rat is not necessarily the position of the collider. See, I had it so that the position of the rat is actually here at the bottom, but then the collider is here. We have the sprite offset by a little bit. We have the rat position. The origin of the rat is the bottom here. And then if we're adding, that would explain why it didn't catch this, because we're taking the position of this. We should be taking the position, the middle position of the collider instead. That should be what we consider the middle. Yeah, he's pointing at the rat. He's out there pointing at rats. Alright, so instead of using that position, do I use position here? I do. Okay, so we should get the moving collider. So we always calculate the moving collider. Actually, wait. Collider offset. We should be considering the middle of the collider. Is that what it is? Collider middle. So we have the collider. We can compute the center. Is that a thing that I have defined? Center. Yes, we do have a way to compute the center. So we take the center of the collider. Is that what I want? The self min, self max. Colliders have things. Okay, there's many things that a collider has. Is that if this was a collider, this would be the min point. This here would be the max point. What I want is, so we have the position of the rat is here. I want to find the middle of this. So we should take, how would that work? How would that even, do we just take the top, we offset the top of this and then we get that there? What am I doing? Yes, we get collider offset position. So we have the moving collider. And then we take moving collider's center as the position. Right? Is that local middle? Let's call it center. Center point. That is our center. I guess the static collider never changes. We can move this outside. Static collider is always going to be here. Tile collider. Static collider. Wait, why are we changing? Oh, because this is defined here. We have this one. I guess we don't need this here. Static collider, tile collider. That's always going to be there. We have moving collider, always compute this. And then we have the center. And now for the center, we take that as our position instead. So we have our next position, we have possible collisions relative to center. I think that might solve it, maybe? Nope. Nope, that is actually much worse. Get the collider offset position, moving collider. You get the center of the moving collider. That gives you an XY coordinate. Get the center, multiply it by this thing. Center plus velocity. So I think we still need this stuff though. I think this stuff is fine. There's too many commented out things here. So we put this up here. we put this up here. We keep this. We get this one. This is fine. All this stuff is probably fine. And then next is going to be center. Center is here. Is that it? Okay, so that does resolve vertical collision. Does it solve this? It does not solve. Okay, never mind. No, what am I doing? This should be so simple. And yet he doesn't even understand. He doesn't even get it, man. What does this mean? What does he mean by this? Okay, what if we were simply to do this? And then, didn't I do this already? I tried this already. You get this thing right here. You floor this one. You seal this one. Wait. That's not it. But like part of this looked more correct, right? No, this is because I was moving. So this is where we're checking, the blue box is where we're checking for collision in those blue areas. Now this one does collide with this one. You know, when we jump up, we are checking this. When we move to the right though, that breaks. Welcome Gray Jumbo, this is art, it sure is. So we are checking these positions. The faster we move, the more positions we check. Look at how far we fell. We are checking all of those positions for collision. And then what? So we still need to resolve this thing. This thing right here is that this guy can still jump through this platform. Is that we are not rounding this down. I need to be rounding down. I guess I should always check the tile before as well. Is that all it is? Is that I actually just need to do this? Is that it? I mean, like, that fixes this, but like, is that what I want? I mean, I guess I guess it does fix it. That means we're always checking the tile to the left though, right? Maybe that's fine. Optimize later. But is it even correct though? Okay, so we can remove these, I think. Because you could possibly just do it with a loss pods. Maybe that is true. Alright, so this does fix this. I think you can just do it with position. Right? Is that true? It's assuming that... No, because then your character could be more than one tile tall. I programmed this in such a way that you are only this tall. But then that doesn't even consider... No, I should be considering the colliders. We should be considering the colliders top and bottom. We shouldn't be considering... we should be considering the tiles, the velocity relative to the top and bottom of the collider, rather than from some central point. Right, so we got moving collider dot min. Right, we got the collider has two fields, min and max. Where the min is the top left point, max is the bottom right point. And so when we're trying to determine where to check, we should be... What are we doing? We should be adding velocity to this. And then do another. So this would be the top left. Moving collider min times velocity. Hold on, we should pre-compute velocity times delta. Which we've already done. We've done this here already. There's too many things being commented out. Get this out of here. I think this is it. So we have next delta. We should be computing moving collider min plus next delta. And then moving collider dot max plus next delta. So this is now where the collider is. I guess no, we could just do this. Hold on. Collider offset. No, the moving collider is already there. Next delta. Offset to position. Moving collider. Wait, what are we doing with this? We're already doing this in another method. Well, anyway. We get another moving collider dot offset by, I guess it would be this. We don't actually need to store this here, I think. So we have the moving collider that has not yet moved, and then we have this one. We should be checking local next possible. No, and then we should be checking. Wait, we should be checking. How are we checking here? Let's draw this out. So let's see. This is the moving collider. We are possibly moving down here. Let's say we're moving here, right? We should be checking. We should be checking anywhere from our current. Okay, so we do need the current collider that hasn't moved yet. We should be checking min of. We should basically be doing like that thing I described earlier. We should be checking like this, and then we should round this out to fit tiles. So like this is the box unrounded, and then we should round this to the nearest tile. So then it should include this as well as this, right? I think that's what it is, because we were just considering this point. We were simply considering these points from here. This was position, and then if we're just considering the middle, we would only be considering this and then rounding it out. But then we should be considering top. We should be considering min of this and max of this. No, but it could be moving the other way as well. Like I assumed we were moving this way. We could be moving upward. So we need to calculate the new min, the new max, and then round those. Okay, I think I got it. So we got next, what is it called? Next possible? Is that even a thing? And then we do min position. Hold on. How do I do? Local x0, y0 should be. How do we do this? How do you even do this? Moving collider dot min dot x. I should just have like a helper that returns min and max of something, because I am doing this a lot. Function of two values. Surely there's a better way to do this, but whatever. So we got get min max of what do you want? What do we want here? I wrote that helper, but what am I doing this for? Get the minimum and maximum of the moving collider dot min. No. What? Should have a thing, some kind of helper. Programming on stream. You always forget what you're doing. Okay, let me reiterate what I'm doing here. We have these two. We want to get the min, but then we don't know which one to get. You could get this one. We might get this one, and this one would be irrelevant. Well, you know it's one of them, though. So we get min top left. Top left equals It would have to be minimum of moving collider dot min dot x moving collider. Sorry, the other one. The next possible collider. And then the maximum is going to be the max y. Or sorry, it's also the min y. All right, so we have this one, top left, and then bottom right. Local top left and bottom right is equal to this thing, except it is the maximum. Okay, so top left, bottom right. Actually, no. Top left, bottom right. I guess these don't need to be wrapped. Just be this. This with top left, top. And what is this one? This one, top left. Minimum. No, we do need. This would just. I don't know. A lot of stuff to think about. Top left, bottom right. Oh, this is top left X. Top left Y. Bottom right X, bottom right Y. Okay, so we have this. And then what do we want to do here? We want to calculate the tiles. We want to know, we should be dividing this by by 8? Is that what it is? Is this true? Chat, is this real? Oh, this should be max as well. Okay, so we got top left X, top left Y. Let's comment these out. I guess this would just be X0, Y0, X1, Y1. I think maybe this is it. Let's try it. Oh, wait. It works? It actually works? Okay, so that's what we that's what we needed to do. Okay, simply just test positioning. So we don't need this. This is fine. Next possible, I could probably name these better, but I think this works for now. Let us remove all of these random drawings that we've done. Where did I draw the bounding box? I don't even know. But look, it works. We got a working collision system. I mean, obviously we still have this thing. That thing is still broken. But I know the solution for that. You just gotta sort stuff. But I figured it out. Isn't that amazing? It only took 2 hours. If you move rightward, it fails. Everything else though, it's good. We got these collisions, we got this collision right here. Alright, let's commit this. We've added many things. Okay, that's where I added this. Let's go back here. Let us remove this. Alright. See what we changed. Should also remove this line. What is that line? Get that out of here. Alright. Got this stuff. We got these things. Render. Partially, I should commit establish a partially working tile collision. Alright, that's it. Good job, me. Thanks for watching. I've explained many things. Hopefully some of this made sense. But I had a good time. Hold on, hold on. I gotta make sure first. Sometimes I forget to git add. Did I git add? Did I add any new files? No, it should be fine. You ever have the thing where you commit something and then you find out you haven't staged your file? Commit-v, I always forget. Okay, everything's been committed. Alright. And they have one commit that just doesn't work, because that's how it is. Anyway, good times. Get rebase and get squash. Alright, let's see what day it is. Let us raid someone. Doggy date night. Carrot cake day, golden retriever day. Painter's day, feed the birds day. Sickle day. Yeah, we're going, oh, sicky. Sicky? I thought that was sickle. Soyapoya, Our Lady of Suyapa. Oh, today's Setsubun. The day the music died. Let's do, Feed the Birds Day. Feed the Birds Day raid. Alright, who do I raid? Who's out there on twitch.tv? Several people. Many people are out there. I am going to send you to a streamer. And this streamer is going to be decided soon by me. Will soon be decided by me. What about this person? Let's draw Kari. Sorry, let's raid Kari Panko. They're doing some art of some kind of collaborative art stream. I don't know. But it's not a collab stream. It is a stream. One of those publicly accessible drawing websites that you can just join. That's it. Thanks for watching. I will work some more on this collision system. I think it's turning out very well. At some point, I will possibly even make a game. Who knows? Ponko, that's basically bread. Yes, that is, I would assume, the origin of their name is that it is probably related to bread in some way. But I don't know. I'll feed the bird. Oh, that's what you meant. Because, like, you often do feed bread to birds. True. So true. Anyway. Good stream. Accomplished so much today. I've explained several things. I've explained collision. I've explained tile search detection. I've figured out the issue that we had. Is that you must consider the bounding box for your tile search. And that's it. Good times. Good day. Good day to you all. I will see you next time. Goodbye.